Hi everyone, this is Gail Queen. I'm doing a quick video to help you understand a little bit more about topic 1, discussion question 2. There were some questions about some students said, well, I could kind of do some of it, but I didn't really understand what was going on. So I'm going to try to explain what's going on and help you with that. So the first thing is when you open the sheet, notice how there's no values. It says, value everywhere. There's no numbers in there. Well, in order to get data to load into the Excel sheet, you have to type in your name. So make sure you go to that blue box at the top and enter your name. I'm just going to enter the name Solutions. So this is my example to you here. Now, when you type in your name, you're going to get data in the first box that says stopping distance, and then you get the first column of data in the predicted values. Now, here's what's going on. They have actually gone out somewhere and they've made a measurement, and they're measuring if you have an object that is traveling at a certain speed in meters per second, then how long does it take for that object to stop? And so over in this column, you see a 4. It says the speed is 4 meters per second. Well, how long is it going to take that, say it's a car or something, how long is it going to take that car to stop if it's going 4 meters per second? And the answer is over here, the y coordinate for that point would be 2.13, meaning it takes 2.13 meters for that car to stop if it's going that speed. And all of these correspond. So you go down the list, these are XY ordered pairs. The X coordinate is the speed, the Y coordinate is the distance for stopping. So they've measured about 6 data points here, and they've given that to you, both the X coordinate and the Y coordinate. And they're saying, based on that data that's given, that that we measured, we want you to come over here to this other box and we want you to predict the outcomes. We want to predict what would the stopping distance be if I was going these speeds over here in this box. So we're going to use the data, and here's how we're going to do. We're going to use the actual given data over here in box number 1, and we're going to create an equation of a line for this data. And I'm going to use that linear equation to help me predict the outcome for the data that's just unknown. Okay, so we need to find a line. In order to find the equation of a line, you need a slope and you need a y-intercept. So remember, the first column over here, column B has the x coordinates in it, and column C has the y coordinates in that. Okay, keep that in mind. Now, to find the intercept and the slope, that's the first thing they ask you to do. These are called fit parameters, intercept and slope. You're going to let Excel do the work for you. So we're going to use the Excel function intercept. So hit an equal sign. You always have to hit equal if you're going to type a function in. Intercept, and open a parenthesis, and we do the y coordinates first. Notice how they're giving you a hint here. It says do the known y values and then do comma known x values. So they're waiting for us to put in the y coordinates. So use your mouse and highlight column C data. Those 6 numbers are the y coordinates. Put a comma, and then with your mouse, come over and highlight the column B data. That's the x coordinates. Close the parentheses and hit enter. That gives you your y-intercept based on these measurements, based on these ordered pairs. We're going to do the same thing to calculate the slope. We're going to use the Excel formula for slope. So we hit equal slope, open a parenthesis, highlight the y coordinates first, put a comma, and then with your mouse highlight the x coordinates, and then close the parentheses and hit enter. So I've got my intercept number and my slope number. If you know the slope and the y-intercept, you can write the equation of the line. We're going to do that in the blue box right down here below. And we would type in, y equals mx plus b, right? Well, we actually need to use the numeric value of the slope, and we need to use the numeric value of the y-intercept. So instead of using an m, we're going to go up here, and the slope is this number in cell B21, but I'm not going to type in all those decimal places. I'm just going to round it to 3 decimals. You can round it to 2 decimals, 3 decimals. It doesn't really give you instructions for doing that, but we'll just round to 3 decimals. So in this blue box, I'm going to come up here to the top, up here where the formula bar is. That's what I've entered into that box. I'm going to click there, and I'm going to backspace where the M is, and I'm going to type in 0.105. That is my slope. And then times X, and then plus whatever B is. B is the Y-intercept. The Y-intercept is in cell B20, and it is 1.297. So I'm going to type that in, and I'm going to hit enter. Now, in my blue box down here, you see the equation. This is essentially y equals mx plus b, but I typed in the number for the slope and the number for the y-intercept. Now, one other thing that you can do, it's up to you, is, this is really the x number stands for the speed of the vehicle, and the Y number stands for the distance that it takes it to stop. So instead of Y right here, I'm going to go back up, and I'm going to change that to a D for distance. That's the distance it takes to stop. And the X number really stood for the speed, so we're going to change that to an S. So D equals the slope times S plus the intercept. So you can leave it with the Y and the X in it, or you can change it to the D and the S. It's up to you, but it really is the same thing. It doesn't really matter if I use D and S or if I use Y and X, okay? All right, so there's my linear equation. Now, if I have this linear equation, they want me to use that linear equation to predict the Y values over here. So in other words, if X is 2, what would the Y value be? Well, remember X or S, I would actually plug it into this equation. I would go in and plug in a 2 for S, but we're not going to do that by hand and type in the number. We're going to let Excel calculate this and do it for us. So in this Y column right here, this is saying what would the Y coordinate be if the X coordinate is 2? So we're going to say the Y coordinate would equal, Y equals, so equals the slope number. So we're going to go right down here and click on the box with the slope in it, times my input number 2. Remember, this is where I'd plug in the X number. So we're going to click on the box where it has the 2 in it. And then we're going to say plus the intercept. And so click on the box with the intercept and hit enter. So notice that it put a number there, but if I click on that box, look up here at the top, it says equals slope, B21 is slope times the X coordinate, E12, plus the intercept. This is Y equals MX plus B, but I'm just referring to the cells where these things are stored. Now, because I want to do this for every entry here, I'm going to do the same thing for the 5 and the 8 and the 11, the 14, etc., except I'm lazy and I don't want to have to type this in every time, one at a time. We can just copy and paste. That is the value of Excel. It will paste the formulas down for you as long as you are locking certain cells. So what I want to do is notice that for every single one of these, I'm going to use the same box for slope, and I'm going to use the same box for the intercept. But the X number that I plug in, that changes. I'm going to use different boxes for that. So what we need to do is go back to the formula here where you typed in the Y coordinate formula when X is 2, and we're going to go up here and I'm going to put a $ in front of that B, and I'm going to put arrow over and put a $ in front of that 21. And that's going to tell it when I copy and paste the formula, don't relatively copy and paste those cells down, lock that cell and use that same slope for every single line entry that I'm going to put. So lock the slope. We are not going to lock the X coordinate, the E12 there, do not lock that. But we're going to go over to the intercept and we're going to put a $ in front of the B and a $ in front of the 20. That's going to lock that cell as well. Hit enter. Notice how it did not change the number here. It just locked the formula cells, okay? Now, because I've locked that, I can copy this formula and just drag it down and it'll fill in and I don't have to type that formula all those different times. So grab that little green box right there. With your mouse, notice how the cursor turns into that dark little cross. that means that you can grab that green box and you can just drag it straight down, and it's going to do that whole linear formula for all of those x values. And I didn't have to type the formula. Yay, that's a good thing. All right, so that just saved a bunch of time by doing that. Okay, so now I have predicted y values. Now I have x coordinates and y coordinates over here, and these are my predicted values. So what this is telling me is they could say, well, you know, looking at your data, you know, how much stopping distance do you think you would need if you were going, say, I don't know, 15 meters per second? Well, I can go over to this predicted value and I can say, well, 15 is really close. That's between 14 and 17. 15's right in there. So if I'm going 14 meters per second, it's going to take me 2.77 meters to stop. If I'm going 17, then it's going to take me 3 meters to stop. And they're saying, well, how long, do you need to stop if it's 15? It's going to be somewhere between 2.7 and 3.0, 3.08. So I'd guess maybe, I don't know, 2.9, or 2.89 or something like that. They're just saying estimate what you think will happen based on these predicted values. So you're using the predicted values to help you estimate what might happen. All right, now we can also do this with a chart, and that's what they ask you to do is put a scatter plot in. All right, so first we put the scatter plot in. I don't think you'll have trouble with this. You saw on the other video that's embedded, so you can highlight the original data, not your predicted values, but the original data, and just make sure you highlight both columns with your mouse, and then go up to the top and do insert, the charts, hit the scatter plot, and it's going to put a scatter plot in here. And we can, make that window a little bit smaller where it actually fits in the space where it belongs. Okay, so let me stretch out a little bit. Okay, and notice that these data points that they gave me, the 6 data points, my data is all over the board. So let's say that I had only these 6 data plots, and they say, hey, use this data and guesstimate how much stopping distance you'd need, say if you were going 12 meters per second. Well, first of all, let's get our chart cleaned up here. Let's change the title of the chart. Let's call it stopping distance. And then let's go ahead and click the plus sign over here. Let's do axis titles. So for the x-axis down here, we can call this the speed, and we can put meters per second. And then over here for the y-axis, we can type, let me backspace and get rid of that, and type distance. This is in meters. Okay, so we've got it cleaned up and labeled. All right, so let's say they ask you based on the 6 data points they gave you, hey, what do you think, what's the distance you think you need to stop if you're going 12 meters per second? So I'm going to go down here to the x-axis, which is the speed. I'm going to go along till I hit 12, which is about right here. And they're saying, okay, what do you think the stopping distance would need to be if you were at 12? Well, look at this data. It's all over the place. I've got 6 random data points, and I can't really tell the trend from that small number of data points. So it would be helpful if I put in a trend line, and the trend line is going to fit my data. It's going to be a line that goes right through the middle of all that data, and it's going to get as close to all of those different data plots as it can, and it's going to tell me what the trend is based on only 6 data points. So to get a trend line, you need to go with your mouse and you need to click on one of those data points, one of those blue points, and then right click on it and do add trend line. And we want a linear trend line. Notice over here at the side, linear is clicked. And notice that that line kind of goes right through the middle of all those 6 data points. And it's giving me an idea of what the trend is based on those 6 points. With that trend line in there, now I can say, okay, what do you think? What's the distance you think you need to stop if you're going 12 meters per second? Well, I go on the x-axis over to 12, about right here. I'd have to kind of guesstimate with my mouse. So 12 is a little bit past 10, not quite to 15. And if I go straight up now at 12, I'm going to go up, and if I'm going to hit that trend line here, and it looks like it would be close to 2.5 meters per second. The y coordinate there would be 2.5. So I can use that trend line to kind of predict and guess what I think the stopping distance would be at 12 meters per second. Does that kind of make sense? So you're using a line to help you predict what might happen. Now, there's a couple of things. They do want us to actually, uh, we can go over here and we can scroll down over on the right side, and we can say, display the equation on the chart. And if you look at the equation that it put on the chart, I am going to move it a little bit if it'll let me. Move it up here where you can see it. So notice how that is y equals mx plus b. And notice how the slope in this trend line that they plotted matches the slope that I calculated over here in my box. They use the same slope and they use the same y-intercept because they're using that same data. So this trend line is the equation of the line that I put over here in this blue box. So it's based on that same thing. So now they're saying, all right, you got your trend line in there. I'm going to close that. So you got your trend line in there. Actually, I need to open that back up. Let me right click and do format trend line. Okay, leave this open for a minute over on the right side. All right, so what they want you to do is use the trend line, but they want the trend line to extend to all of the numbers that are included in your predicted data. So over here in the predicted data, notice how it starts. My first predicted data point is 2, and my ending x coordinate is 32. Well, if I start at 2, well, start at 2 and end at 32 on the, say you look at the x-axis, my actual data that they gave me starts at 4 and ends at 24. Well, to get to 2 to 32, I need to extend the 2 goes a little bit back from the 4, and the 32 goes beyond the 24. I need to tell Excel to extend my trend line and extend it back to 2 and out to 32. So the way you do that is you will go, let me get back to the screen where I am formatted the trend line. Okay, so go down here and we want to go forward. All right, so it was my ending X value for the data was 24. My ending X value for predicted data is 32. So I need to go forward from 24 to 32. I need to go forward 8 more units. I ended at 24. I needed to end at 32. So you need to move forward 8. So we are going to go into the forward box and type an 8. And then I need to go backwards. The trend line currently is starting at 4 because that's my first X coordinate. I needed to go back to 2. So I need to back up 2. So from 4 to 2, I need to back up 2 units. And now if you look at the trend line, it is extended now where it looks like it's starting at 2 and it goes all the way to 32. So that gets all of the data that they've asked me about. Now, one last thing on the video, this has troubled some students. It shows the red data points along this line. These are going to be the actual XY coordinates of these predicted values. If you want to plot those, these data points are going to fall right on that trend line because I use the trend line to predict those Y coordinates. So to put those on there, we can go, let's see, we right click and where did I find that? All right, oh, there it is. Okay, sorry, I had to remember what I did. He did not tell you this at all in the video, so I don't know how he expects you to know it. You would click on go to your trend line and right click, and it brings up this box. Hit select data. And what we want to do is we want to tell it to use our predicted XY values and add that to our chart, add that to the graph that we have. So we're going to go to this little button that says add. We're going to add some data. The series name, we're going to call it predicted values because that's what we're adding. And it says, tell me what the X coordinates are for those predicted values. So click in this box where it says series X values, use your mouse, make sure you're clicked in that box first, and then go over here and highlight all of the X coordinates for your predicted values. That would be in column E. So you have that highlighted. Now go down to where it says series Y values, click in this box, backspace and get rid of the junk that's in there, okay? So all that's in there is your cursor, and then use your mouse and highlight the Y coordinates here and hit OK. And notice how, hit OK again, notice how now all of those predicted values show up in those sort of orangey red spots, and they're right on the trend line. And that makes sense because I used the trend line equation to find those points. So that is the extended, the extended out trend line, and it has the predicted values on it now. So now we can scroll down, and I can close this finally, and we can scroll down and say, okay, you can use the graph. And I'm not going to answer this question for you, but use the graph and approximate the stopping distance at a speed of 27.5. Well, that's kind of like when I was saying, predict what happens when I'm at a speed of 12. And I went right up to the line and said, it looks like it's about right here. So use your graph and predict what your stopping distance would be if your speed was 27.5. So you go over to 27.5 and tell me what your predicted stopping value would be. Then in the bigger blue box, it says for every 1 meter per second increase in speed, there is a blank meter increase in stopping distance. This is your slope. Slope is going to be, if I go over 1, how much, what would the increase in stopping distance be? Use your slope to help you there. And then it says if the speed was 0, meaning the X coordinate is 0. So if the speed is 0, then the stopping distance is predicted to be what? Well, it's the same thing. I went over and said, well, if my speed was 12, I can look at my chart and go up and say, what's going on that line at 12? If it's 27.5, I go over to 27.5 and I look at that line. If it says your stopping speed is 0, go over to where it's 0 on the x-axis and go up and predict where your line would be if the X coordinate were 0. And it looks like mine would be, say, 1.3 or something like that, 1.3 meters. So it's asking me the question, if the speed is 0 meters per second, the stopping distance is predicted to be 1.3 meters. This does or doesn't make sense because of why? Well, you tell me. If I'm going 0 meters per second, I'm not going very fast. I'm going 0. Do I need a stopping distance of 1 meter, 1.3 meters? Does that make sense? Okay, I'm just going to kind of leave it there for you to kind of think about that and figure it out. But all they're doing is they're wanting you to use a line that goes through the data that was measured and use that as a predictive trend line so you can predict the outcomes of what would be even beyond the actual data that was measured. All right, so I hope that kind of makes sense. It's not that bad. It's not nearly as bad as you're making it. So I hope this helps, and I will see you in the discussion questions, and I'll see you in the next video. Have a great afternoon or evening.